Programming 12, welcome back. I am going to attempt to do some drawings. That will be exciting. I think that will be embarrassing, and I hope you laugh a lot, and I will not be offended if you make fun of my drawings. But I'm going to try and explain as best I can through this format how the mouse movement will control your focus location to basically be turning your head all over the place. It's going to involve some trigonometry, which I know you all love. And I honestly do. I mean, is love too strong a word? Maybe. I don't know. But I really appreciate the trigonometry stuff. And it'll be simple trig, like stuff that you used in the past to figure out how far a ladder was away from the wall, and those real basic trig questions that you had in your math 10. Yeah, I think math 10 workbook. Those like basic ones. That's the only kind of level of trig we need to know. Okay, so I just want to remind you what we're up to. Here is we got our focus points illustrated now out there in the world. Oh, I'm in the wrong one. This is what we're going to do. I don't know if we'll put the ceiling on, but somehow I flipped over to the wrong one. Here we go. Here's the current one that we're working on. That's the one that you're gonna get to. Sorry. Here we go. There we go. Yes, so this is the boring, I can just move around. Pivotal that we have that dot there. That's going to really make this work. So let's take a look and see what's happening here. I will. What do I got here? Yeah, there we go. Whew, look at this old drawing app. It's called Sketch.io, and I think it's going to help us to illustrate this. So what I'm going to draw here is sort of a top-down look at our 3D environment. So I'm going to have looking from above our camera. I'm going to choose a clip art thing for our camera. The default is cow. Can we find a camera? Nah. What should we find? Something cooler than cow. I don't know. I'm wasting our time here, really. Let's just go with the cow. Cow's cool. I don't know the cow. Let's put in the cow. Go. Put in the cow. How do I do it? Just there we go. Okay, beautiful. There's the cow. So this is going to represent our character. And remember, we're looking from the top down, despite the fact that the cow's eyes are pointing at us. Make no mistake, we are looking above. So if this was, Minecraft, we'd be floating above. We'd see the top of Minecraft Steve's head or whatever your avatar is. So I'm going to attempt to draw in. Oh, come on now. That's too much. That's too much. I'll draw in the sort of the axes. So here's our axes. So, if we're looking from above, then, that's not that straight, but it's okay. We can imagine. That's going to be our x-axis, right? And this will be our z-axis, just like in Minecraft. The sort of ground, if you will, this is supposed to be my z. The ground is the XZ plane that you walk around on, and you're going to go up and down, but we're looking from above, so, that's sort of how that would look. Hopefully that makes sense. So now, if we are looking from above, where's our focus point? Well, right now our focus point is sort of projected like 300 pixels directly out from our camera. Like about like here. That's like our focus point there. But it won't be there for long. We want to basically be able to move it around, so maybe we can move it over here. And then our camera, will turn and face towards that, right? And we want it to kind of, oh no, I don't know what I've done now. Like I said, you're more than welcome to laugh at me for this drawing. Let's drink it back. Come on, cow, don't get too big. We want to basically be able to move it in this, it's a pencil. Basically be able to move it sort of in an arc all the way around our camera, and wherever it goes, our camera will point in that direction. We're not going to worry about looking up and down right now. We're just going to worry about the XZ plane. That's going to be our first start. So let's figure that out. I'm gonna get rid of what I just drew because it's ugly. And I'll take this, and just to illustrate a bit, I'll kind of rotate it over. We already know what it looks like right now, but I would like to be able to figure out, how do we position it over here? So what's going to happen is that we're going to use the mouse not to control directly this position. We're going to use it to control the angle. As the mouse moves, we're going to increase and decrease the angle. And then what we'll do is we'll recalculate the new focus X and focus Z. Later on, we'll do the Y as well, but that'll be a separate thing. So, it was over here, but I want to rotate it and move it over here. So what does that math look like? So let's take a look at this in, your trigonometry zoom in sort of thing. So I'm going to draw this angle. And of course, trigonometry is all about right triangles, and angles always turn out to be nice right triangles, right? So here is, didn't really nail that right angle, but I was doing so well too. Some of those lines are pretty good. So here's sort of the what's going on. It was facing, up here, but we've rotated over here. And this is going to be our angle here. I'm going to call it theta because, gosh, it's trig. What are you doing if it's not theta? In our program, I won't call it theta. I'll call it, left-right angle or something like that. But there's our theta. What's this distance? It's clearly a hypotenuse, right? I'll write in h for hypotenuse, but we know how long that distance is. It's not unknown. That's a 300. That equals 300. This is slow going, I tell you. 300. Ooh, I'm writing so slowly. Okay. So that distance here, that's our hypotenuse. It's 300. How do I know it's 300? Because I am projecting it 300 away from this. Otherwise, the other coordinates are the same. This will change, by the way. It won't always, these things will change, but I can guarantee right now that I want to keep that distance 300. No matter where it goes around in the circle, that radius is going to be 300. So then we, of course, have the opposite side and the adjacent side. And if you were to just look at this, here's the opposite, here's the adjacent. Opposite is got to be your z coordinate, right, of this thing, because it's, parallel with the z-axis. The adjacent side has got to be your x component of where this is. So that's got to be it's got to be the x component. So we basically are solving for opposite and we're solving for adjacent in this triangle. So how do you do that? Well, you use cosine and sine, right? That's the whole thing, the whole SOHCAHTOA beautiful acronym that helps us remember how do we calculate one of these sides of the triangle. So for example, if I was to if I wanted to calculate maybe this component, this is our z component, I want the opposite side, right? So I have opposite. I want opposites. I have hypotenuse, which is that? What ratio is that? Opposite, hypotenuse. What is it? SOHCAHTOA, right? So sine, S-O-H, right? So that helps a lot. So I want to take the sine of theta. Basically, the sine of theta, I don't know if it's worth it to type it out here. I'll write it. So sine theta equals opposite over hypotenuse, right? Opposite really represents our z component. So opposite over hypotenuse. Hypotenuse is 300, right? And I can, to solve, this O is, I'm going to make it op because it looks like 0 over 300. So the opposite side, to solve for that, I'm going to just basically multiply both sides by 300. So 300 times sine theta. Times, I'm having trouble timesing here. Times sine theta. Oh, yeah. Aren't you glad you tuned into this video to watch me type so poorly? So that's the opposite side. I will spare you the adjacent. Because what's the adjacent? Well, it's adjacent hypotenuse. It's cosine, right? You probably already are familiar with these things since you've done math before. It's a grade 12 programming class. So cosine will give you the adjacent. So a similar kind of calculation will be used to do that. What ultimately are these going to give us? Well, they're going to give us the new coordinates of where our focus point should be. And we're going to control theta. We're going to control that angle and then use math like this. We're going to turn that into code to reposition the focus point to turn our camera. That's it right there. Does this make any sense? I hope it does. So, okay, we're going to go and do it in practice. So I am going to go ahead and make 2 new variables. We'll make float. I had some names for it. I have left, right, head angle. That's the name. We're also going to make an up, down. Oh, let's put it in here. Up, down, head angle. And we won't use it right now because we're just going to focus on side to side, the XZ. So let's go and add in this stuff. So I guess left, right, head angle. Should we initialize it? Let me just think about that. Left, right, head angle. I think I'm going to leave it for now as 0, but I might change my mind about that. So I will put it in my setup. I will put in a left, right, head angle equals 0, but I might choose to change that. I reserve the right to come back and change it. So let's go down to control camera. So what I'd like to do is sort of add in additional trigonometry in here, basically, to recalculate the x and the z. I'm actually going to move the x and the z together and put the y separately so that we can kind of focus on these together. So focus x and focus z. If we look at our beautiful picture, remember the opposite side, that's z, right? And that's going to be sine theta times 300. And theta is that new variable we made, the left-right head angle. So we're going to take not this, but we're going to take, actually, and I think I'm going to just do plus instead of minus, sine of left-right head angle times 300. That's basically just this math here. That's calculating that distance. Like, how far up is it? We're also going to calculate, sorry, wrong one. The same thing for x. That's going to be the cosine. Left, right, head angle times 300. And our angle is 0 right now. So, we'll see what we see. I don't think we'll see anything too different. Here we go. We'll run it. But you'll notice that up and down now take us left and right. If you press W and S, they're going this way. And you might be like, did I break the keyboard? And the answer is, well, we just actually turned our head over to the right. And so now we're moving forwards and backwards. We're actually still controlling. You can see it down here in your printout. So you can see in the console, we're still changing the Z coordinate, but it's like we've turned our head and we're moving back and forth and we're seeing sort of the scenery move to the side. I'll demonstrate. We can move our left-right head angle. I can change the head angle. I can make it, well, I can't quite make it 45 degrees. I can say radians, 45. If you recall, processing uses radians. So whatever 45 degrees is, we'll turn it to radians. And you'll see now that we have like a slanty floor. I still move along the grid lines of the floor when I press W and S, and same with A and D, right? So it looks like it is correctly kind of moving our head around, but I don't want to have to manually do this. This is kind of annoying, but just to kind of demonstrate, I can stick it to 90. Now let's just get it to a good, place so that we're still moving correctly. 90 degrees. It looks like it's not quite facing the right way. Let's go 270, I think, is where we were originally facing. So this will kind of get us back to where we're supposed to be, at least at the beginning. There we go. So things are back to normal. So now what we can do is we can change that. So this calculation, by the way, sorry to jump around, that's just in setup. So that's just sort of how we start facing. And then this stuff is working correctly. We saw because we changed the angle around, it was rotating around. All we need to do now is control this angle when we move the mouse. So that's going to be easy to do. I am going to, where should I put this actually? I'm going to just inject it right in here. We're going to put in some mouse code right in here. And what I'd like to do is just sort of like, as I move the mouse to the left, I will decrease the left-right angle, and as I move it to the right, I will increase it, and so on. So here's what I'm going to do. I guess you might wonder, how do you know which way the mouse is moving? So what I'll do is I will change left, right, head, angle equals left, right, head, angle plus. That's kind of annoying to have to type it twice, but that's okay. I'm going to say mouse X, because it's like when we move the mouse left and right, that's when we want to rotate, just like in Minecraft, right? Mouse X minus P mouse X. So this is going to be taking the difference between where the mouse is and where the mouse was last frame. So if I'm moving this way, then my previous mouse X will be greater, because where I was compared to where I am now was a bigger number. So when I do that subtraction, it'll become negative. So that means it'll decrease the angle when I move my mouse to the left. When I move my mouse to the right, it will increase because P mouse X will have been smaller. So I get a positive number. This is going to be wild. When we do this, it'll look dumb. So I apologize in advance. So just hold on for a second. Let's take a look at it. And as I move, you'll see it moves so fast. It's like, wow, just crazy fast. You can get the sense like that it is working, but it sure looks goofy. So this is just too much. Remember, we're using radians, where around the circle is 2 pi, which is like 6 and change. So a difference, like you move your mouse, like just a twitch moves it like 6 pixels. So let's times it by some really small number, like 100th. So we really reduce the sensitivity. By the way, this number could be your mouse sensitivity, so you can make it a variable to adjust it. For you CS:GO players and other first-person shooter games, you want that mouse super sensitive, like that number could be smaller or larger depending on your preference. Okay, so let's see what it looks like now. There it is. There it is. Look, I move my mouse this way. I decrease the angle. I move my mouse this way. It increases the angle. If that's still too fast for you, that's okay. You can change it. You're most welcome to change it. Yeah, and it looks good, right? It looks totally good. It looks as good as you could want. So it works. Also, notice that when we move left and right, it's still locked to the grid. Like I can move left and right, I can move over here, and I still move in that same direction. I'm still moving in the Z axis, and this is moving me in the X axis. That's still not quite what we want, but it's a pretty good step in the right direction. Wait, I guess okay, no. I was going to make a joke about stepping. We're not really stepping in the right direction yet. We're stepping in the X and Z directions. Nonetheless, that'll come soon. You'll also notice that the mouse and the focal point aren't really the same. It feels a little weird because in Minecraft, you sort of think of that crosshair as where the mouse is. But it's not really. So that's okay. But we'll get to all these details. It's working nicely. We're going to do the same thing that we just did for focus Y, but that's actually going to be a separate calculation. So that's going to be the up down head angle And we're going to say up, down, head, angle, sorry, equals up, down, head, angle, plus, and this time, yeah, we're going to use mouse y minus p mouse y times 0.01. Why is that? Well, now we're moving up and down. We want the head to look up and down. So it's the y that goes up and down, right? That's what the mouse is controlled with. So that's going to control our up and down. And then this is actually going to be tangent. Tangent of the up, down, head, angle times 300, I believe. Same hypotenuse. I won't go too much into this. I think I'll explain that in class. Might be easier to explain with some diagrams and stuff. My drawings are pretty bad, so I'm just gonna. I'll get back to tangent in a bit. So I guess I'll go off in a tangent in class to explain this. Oh, it's so bad. Okay, so let's just see, how does that look? I think it's gonna be really weird because the zero is gonna like. Oh no, it's not too weird. But yeah, now you can see like I can look up and down, and I can do some weird things. I think if you recall tangent, the graph for tangent, you get to infinity and then like it loops back around. I don't want to be able to do that, so I'm gonna have to lock in to make sure my angles don't go too far. So I'm just gonna put in a little bit of code because tangent, the way the graph works and the way the ratio works is, you will go from negative infinity to positive infinity. So basically, I'm looking down and I look a bit further down. All of a sudden, I'm looking up. I don't want that to happen. So I'll add in some like some sort of up down head angle math. So if up down head angle is greater than, and I'm gonna I guess use radians here. So pi divided by 2 is 90 degrees, but it doesn't quite. I don't want to get to 90 because tan of 90 and like negative 90 give me those like ridiculous numbers. So I'll do 2.5. Won't be not quite 90 degrees. It'll be like 80 degrees or something. I'm not sure exactly what that works out to, but some smaller number. So if it's greater than it, then I'll just set it to that. So up, down, head angle equals pi divided by 2.5. And the same thing if it's less than negative. I'll do the same thing. So if it's less than negative pi, I have to change this. Then I'll set it to negative pi divided, roughly 80 degrees. So let's see, does that sort of lock me in from flipping around? Let's see. Yeah, see how I kind of, bam, I hit the floor? Boof. If I look up, I also hit, we don't have a ceiling. You might want to program that in just to see it, but that sort of gives me that. Yeah, it looks good. One last thing, I'll just turn off my cursor. I think it might be nice to just, I'm going to go to my setup. I think I'll say no cursor, and we'll see the cursor disappears. And you start thinking of that focal point almost as like your cursor, right? It's not quite though, because if I go far enough, my mouse pointer, did you see that it kind of came off and goes back in? And you might think, wait, that's not how Minecraft works. Your mouse moves, you can just keep scrolling. So in our next video, we'll do one more thing where we take a look at how we can get the mouse pointer to wrap around. So it's not quite how Minecraft works, and I don't know what the proper way is to do that there. But we'll do something that works pretty well. That'll give us approximate feeling. But look at this. This is looking good, right? We're still locked in to those coordinates, but we're able to look around, sort of on a railroad with a turret as we move. But it's working. It's working good. And it was probably pretty fun for you to put together. At least I hope it was. Anyways, thanks everybody. We'll see you in the next video where we're going to take a look at, I guess, two things. What I just said was getting the mouse to sort of stay inside of the screen, and then also walking in the direction that our head points in, the direction our camera is pointing in. So that's the next video. Thanks, folks. Great time.